Hello dear students, this is problem number 26, chapter number 24. So we have a figure 22. We have three conducting plates, each with area A, are connected as shown in the figure 22. Are the two capacitors thus formed in series or parallel? Okay, so remember that as we know that the upper two plates that are connected to same point, same potential, the upper two plates are connected to same potential. So as we know that the two plates are at the same potential, so these two plates was negative. They are connected to the battery negative potential, while the middle one is connected to battery positive potential. So as we know that the upper two plates left end are connected to same potential, and lower middle plate is also connected to the same potential. So if potential is same, this is the parallel combination. This is parallel combination. So for part A we can write as upper and lower plates are connected to same potential, thus this is parallel combination. This is parallel because we know that in the parallel combinations the potential will be the same. Okay, for the part B, determine capacitance as a function of D1, D2 and A. So the capacitance C, B part. So in order to find the capacitance C, so first we write for C1, capacitor for first capacitor C1. So capacitance formula is epsilon naught A over D1. We know that this separation between the plate for first plate is D1. So we can write epsilon naught A over D1, and similarly for capacitor 2, epsilon naught A over D2. The separation between the plates is D2. So the total capacitance, because we know that these are the parallel combinations, so that the total equivalent capacitance C total is equal to C1 plus C2. So we add to get the total capacitance. So because we know that in the parallel combination total capacitance can be found by just adding these capacitance. C1 is epsilon naught A over D1 and C2 is epsilon naught A over D2. So further we solve C is equal to C total, or C is equal to, that is equal to epsilon naught A is common, and we have 1 over D1 plus 1 over D2. 1 over D1 plus 1 over D2. So we can take the LCM. So we can write C is equal to epsilon naught A, D1 and D2. So we can write D2 plus D1 or D1 plus D2. So C is equal to epsilon naught A, D1 plus D2 divided by, so we take divided by D1 D2. Okay, so C part. So for the C part, the middle capacitors can be moved, so that we move this middle capacitors by changing the value of D1 and D2. So that what is the minimum maximum capacitance, the net capacitance. So if we so first we find the maximum capacitance. So for maximum capacitance, so in order to solve for this maximum capacitance, so let us modify this total capacitance formula. C is equal to epsilon naught A. So suppose that D1 and plus D2 is length L. D1 plus D2 is equal to total length L. So that D2 is equal to L minus D1. So we just modify this equation. So L1 plus L, D1 plus D2 is L, and D1 and D2 is L minus D1. So this is the modified equation, that is equation number 2. Now we can find the maximum capacitance. From this formula we can say that if L is equal to D1, sorry, if we know that the if L is equal to D1, L is equal to d1, mean if we change this value of d1, I mean the middle place, we move this place towards the d1, so that the L1 and D are the same. If we move this plate so that the L and D are the same, total length between the capacitor L is equal to the D1. So if we move this plate toward the bottom, so this D1, this distance D1, it shift towards the L. D and L1 are the same. So if L and D1 are the same, so that this formula L minus L becomes L minus L, that gives us 0. So this is maximum capacitance is infinite. It will give us infinite because epsilon naught L over D1 into L minus D1. Instead of D1 we can write L. So L minus L 0, this makes 0, and epsilon naught A into L over 0. So this will give us infinity. So this maximum capacitance becomes infinite. So the capacitance become infinite if distance L is equal to D1. Okay, now for the minimum capacitance. So the minimum capacitance is requirement is that minimum capacitance requirement is that L is equal to D1 by 2, just the halfway between. The minimum capacitance requirement is that D1 becomes L by 2. So D1 becomes L by 2. So the middle plate, so this is D1, this is D2, and the length, the total length is L. So if this D1 becomes half, so D1 is equal to L by 2. So this is the minimum capacitance if the central plate is at the middle. So this is the minimum capacitance. So for the minimum capacitance we use the same formula, epsilon naught A over epsilon naught A D1 plus D2 over D1 into D2. So the modified formula, we use modified formula. So this is L, modified formula, L into D1 L minus D1, that already we discussed here in the above, L over D1 into L minus D1. Okay, so epsilon naught A, now L over D1 becomes L over 2, so L minus L over 2. So this will give epsilon naught A L over 2 minus L over 2. So L, this one, this L will be cancelled. So 2 to make 4, 4 epsilon naught A over L. So this is the minimum capacitance condition. C minimum is equal to 4 epsilon naught A over L. Okay, so this is C minimum. The minimum capacitance is 4 epsilon naught A over L. So L can be, we can also replace C minimum is equal to 4 epsilon naught A over D1 plus D2. So this is the minimum capacitance. Okay, thank you.